In this lesson, we will talk about expected value. We will introduce this concept by using this example number 3. We have a brand of a SUV tire has been extensively tested over rough terrain. For any set of 4 tires, let x, the random variable, be the number of tires that fail the test. It has been determined that x has a distribution given by the following table. So we have that x is going to be from 0 to 4 because it's the number of tires that fail the test, and we are given the probabilities. First, fill in the last probability in the table above. Well, we are not given this value over here, but we are given the rest of them. And if we sum those values, we can see that the sum is 0.99. Okay, so we are missing, remember that the sum of all should be 1. So this value that we are missing should be 0.01. Now, summarize the probability mass function, the PMF, with a graph from 0, 1, 2, and so on. And here in the x-axis, we plot the PMF that is equal to the probability of the random variable taking those values. And we have that they range from 0 to 0.5. So our plot is going to be like this. So this is an approximation of the PMF, right? Now, what is an expected value? The expected value, or also mean or expectation or the average of a random variable, describes the center of the distribution. We can examine the graph of the PMF for the random variable x, and if this graph were representing physical mass, where would the center of mass fall approximately? In this example, if we try to approximate the center of mass, I will say this will be over here, right? Should be around 0.8 or 0.9, we don't know, but we can calculate it, okay? So we calculate this mathematically with a weighted average, weighting each possible outcome by its probability, and that's how we find this center of mass, that this expected value. So for the x in example 3, we calculate this expected value. The expected value is going to be a weighted average, so we will have the possible values of x multiplied by its probability. So it's 0 times the probability of x being equal to 0. And we will do that for all the possible values of the distribution. 1 times the probability of x equal to 1, and so on until 4 times the probability of x being equal to 4. And if we do that, this is going to be 0 times 0.5 plus 1 times 0.3 plus we have this table 2 times 0.15 plus 3 times 0.04, and the last value that we found, 0.4 times 0.01. And if we do that, this is going to be 0.76. And this is actually the center of mass for this distribution. We have two properties here, so you can remember the expected value of x is a constant, it's a number, okay? It's not a function, it's a number, and the expected value doesn't have to fall or to be, let me put to be in the support of X. So remember here that, for example, the support are the natural numbers, or the integers, 0, 1, 2, 3, 4, 5, 6, and so on. And the expected value is 0.76. It's a non-integer number, but it doesn't matter. The expected value doesn't have to be in the support of X. The formal definition is that the expected value of a discrete random variable X, whose distribution possible values are x1, x2, and so on, is defined by the expected value of X equal to the sum over all possible number sets of X times the probability of the random variable taking those values. So the expectation is undefined if this sum diverges. Consider this example. Let X and Y defined in example 1 calculate this expected value. So remember that we had Y to be, let's remember this example over here, this Y, -1, 2, and 5. So we have Y is -1, 2, and 5. And the probability of Y taking those values was 1/4, 2/4, and 1/4. Right? So what is the expected value of Y? Well, it's going to be the expected value of 3x minus 1, because Y was defined as 3x minus 1. But we can calculate this using the formula. This is Y times the probability of Y being equal to Y, right? And this is going to be -1 times 1/4 plus 2 times 2/4 plus 5 times 1/4. If we do this calculation, this is going to be 2. And if you remember, if we plot the PMF, we have here -1, we have here 2, and we have here 5. So let's put the probability of Y being equal to Y. And here we have 1.5 and 1/4. So this is the PMF for this distribution. And the expected value, the center of mass here, is obviously the number 2. Consider X, and this is another example number 6. Consider X and W defined in example 2. Calculate the expected value of, this is W. Remember that W was X -1 square. Remember that W was, let's remember, W was 0 and 1 with probabilities 1.5 and 1.5, right? So W is 0 and 1, and the probability of the random variable W is 1.5 and 1.5 for 0 and 1. So the expected value of W is basically 0 times 1.5 plus 1 times 1.5, and this is 0 plus 1.5, and this is 1.5, right? So if we sketch the PMF function, W takes just the value 0 and 1. The probability, this is the PMF of W, and we have this is 1 and this is 1.5. The PMF is going to be this. So the center of mass here is obvious, that is 0.5, and it's actually the expected value. This is 0.5. This is the definition to calculate expected value rule for functions of random variables. If a random variable X has PMF p of x and gx is a function of x, then the expected value of the function of the random variable is the sum over all possible values of x of the function evaluated in this number x times the probability that the random variable takes those values. So that means we don't need to calculate the transformation. We can use the original random variable and calculate the expected value of the transformation. So you can check the proof of this if you are interested. The proof is in the pages 84 and 85 if you want to check it. To illustrate how this works, how this expected value rule for functions of random variables works, we can use the same example seeds. We can calculate the expected value of w, but instead of calculating the expected value using the formula, we can use the transformation. So the expected value of w is the same as the expected value of x minus 1 to the square. Remember that w was defined as x minus 1 square. And this expected value, according to this formula, is going to be the transformation evaluated on each possible value of x. So this is going to be 0 is the first possible value of x, 0 minus 1 squared, times the probability of x being equal to 0. And if you remember, this probability was 1 over 4. So this is going to be 1 over 4 plus the other possible value of x is 1 minus 1 squared. This is the function evaluated in 1 times the probability of x being equal to 1, and this is 1. This was 2 over 4, is the same as 1.5, plus the other possible value of x is 2 minus 1 squared times 1 over 4. And if we calculate this is going to be 1.5. So the expected value of w, that is the transformation x minus 1 squared, we can either do the transformation and calculate the expected value using the formula for the expected value like this, or we can use the formula for functions of random variables like this, and we have the same result, 1.5 in both cases.